Well, hello. So the purpose of this video is to review the concept builder, a couple questions from there, concept builder from physics classroom, freefall. A common question I've received is folks will look at this, and the first thing I always try to point out is acceleration should be the easy one. Acceleration is always downward at negative 9.8 meters per second squared. So acceleration in free fall, keyword there's free fall, is always the same. It's always this value. So it remains constant, it's never changing, it's always downward. This answer here is unchanging. Now velocity, on the other hand, is a little more tricky to think through. Sometimes it's useful to input the word speed and then direction. When we think about velocity, because velocity is speed and direction. So sometimes if you're reading the story of this and explaining what's happening, so obviously that would remain constant there. So if we read this, what changes in the velocity as it rises towards its highest point? Well, hopefully you could think through if the baseball's rising towards its highest point, if it's being thrown straight up, hopefully you would have a sense that it's slowing down. And so in this case, the speed would be decreasing, and so we could say the velocity would be decreasing. Now I've had a couple people thinking about this and saying, well, if the velocity, if it's going downwards and the speed is increasing, is the velocity decreasing because it's getting to be a bigger negative number? And physics classroom is really thinking about this just in terms of doing this. Is the bigger number for velocity, a bigger negative number would still be increasing, whereas a smaller number would be decreasing. So that's why we're at decreasing here. Another type of question you'll see is something that could look like this. Now this one already has the correct answers in it, so I would remove that as if we didn't know the correct answers. And so what it would say is, you have a ball that's traveling. This is something you just kind of have to read and process. So it says the speedometer reading 3 seconds after launch is shown to the right. That's this one. And it says the ball is moving upward. That's a critical detail. And so what I recommend doing is making essentially to start writing some stuff down. And what it tells you is at 3 seconds, it says it's at 40 meters per second, and it tells us that it's moving upward at that time. So I tend to think of upward on the left and downward on the right. I don't know that there's any good reason for that, but I just draw an arrow there to say it's going upward at 3 seconds. From this information, we can create an entire table here. We know that something's happening at 3 seconds. We can go backwards and say, well, 2 seconds, 1 second, 0 seconds. It had to start at 0, and we know that it's getting subtracted away, so we know this number is getting bigger as it goes down. So this would be 50, 60, 70. These are, of course, all meters per second. The trick to this is making the table. Well, we know that if it's going up this way, so these work backwards to 0, the time. This has to go up to 0 because it's traveling up until it's going to stop. And so then we could say 30, 20, 10, 0. And we're doing approximately, we're using, for these, you want to be using the fact that gravity, acceleration due to gravity equals approximately negative 10 meters per second squared. I should have clarified that on these. That's why we're getting up by 10 or down by 10. And so our time would continue on. We could have 4 seconds, 5. Now, what this tells us is at 7 seconds, it comes to for the briefest moment in time, it is at a rest, smallest amount of time imaginable, and then it immediately starts moving back downwards. And you don't want to say that a whole second later. So 1 second later, this is going to be at 8 seconds. It's now moving at a negative 10, so now it's going downwards. But then we could continue the table up. So we can see throughout this that the entire flight would take 14 seconds. At any given time, we can see, for example, at 20 miles per hour, it would read both at 5 seconds, and at 9 seconds, it would be reading 20 meters per second, not miles per hour. So from this table can all be created from this original piece we did right there. And so the question is, at what approximate times does the ball have 0? Well, that's going to be 7 seconds, as you can see, because the meters per second is 0 at 7 seconds. So that's why that's 7. And then at 30, it's actually 2 options. And I believe if you click through this one, 30 has a total of 2 options here. Obviously, it could be 10 or it could be 4. One's going up and then one's coming down. But if you click through here, I believe it won't let you select 4.
Am I interrupting? I can go.
All right, I do apologize for that. Everyone can try to guess who that was, the teacher in the building. So the question there was, the second question, at 30 seconds, there's 2 places, as we mentioned, 4 seconds and 10 seconds. It doesn't actually tell us which one, but since 4 seconds isn't an option, it lets you pick 10 seconds on that one. There's one more of these that's a tiny bit harder. I want to point out at least how you would make the table. This one tells us a ball is launched straight upwards. The speedometer reading is 4 seconds. After 4 seconds is shown here. It's doing 10 meters per second after 4 seconds. Critical detail here, it says the ball is moving downward. This is a pretty big deal to us because it gives us some information when we're trying to recreate that table. And here what we know is at 4 seconds, the ball is moving downward, but it's at 10. So there I would put 10, and then I would make my little down arrow showing it's over here. And notice I put the time on this side because I normally just do show convention with it going downwards on the right, up on the left. So here we have to work backwards. We can't actually go down this way because we don't know for sure where that's going to end. We have to kind of go back up around this way. So we're really sort of interjecting at 10 right here. So then 1 second before this, we could say at 3 seconds, 1 second prior, what was its velocity? Well, it would have been at 0. And then 1 second before that, that would be at 2 seconds. What would it be? Well, it would be at 10 again. And then now this continues to count down to 0. And so then we would have 20 and then 30. These are all, of course, meter per second. And then we can finish this side out, 5, 6. So again, this initial piece of information we get right here gives us enough to fill this out, but you just have to process that. And then you can, of course, answer the questions. It's asking at what approximate times of the ball be moving upward. Watch those. It's going to say upward or downwards, and it depends. And here, since it's both upward, we're looking at 20 and 30. So our answers would be 20 and then 30. So 1 and 0, as this shows right there. Thank you. Best wishes. Hope you have a great day.